Did you know that the average cow weighs 1 ton and drinks 35 gallons of water every day? Livestock production is a leading cause of global warming, producing up to 51% of greenhouse gas emissions and causing 91% of Amazon forest destruction. Nearly half of Earth's ice-free land is occupied with animal agriculture. Cattle are a leading environmental issue, especially in terms of soil impacts. Between 1940 and 1990, the number of cattle in the United States increased by 60%, becoming an integral part of our society and the complex ecosystems in and around their pastures. These maps illustrate the extensive spread and density of cattle in the U.S. This extremely dense spot is Malheur County, Oregon. This is the site of recent violent controversy involving a ranching family and cattle grazing on federal land. Due to decades of grazing mismanagement, local ranchers opted to graze cattle on public lands to fight off economic downturn, illustrative of the worldwide link between soil mismanagement and economic and social unrest. Both grain-fed and grass-fed cattle rely heavily on agriculture and land usage, therefore they both have an impact on soil and surrounding environments depending on grazing intensity.
A cow's weight on the earth may seem insignificant, but the vertical stress applied to the soil when a cow's mass is concentrated on 1 or 2 hooves at a time is significant, and cattle tend to graze the same paths multiple times.
The pressure they exert directly reshapes the earth and compacts the soil. This increases runoff rates and redistributes soil water saturation. Some areas that were previously water-rich may be subjected to overland flow, while others downland may become supersaturated. In riparian zones, grazing decreases erosional resistance by reducing vegetation and exposing more vulnerable substrate, causing erosion. When cattle trample the soil, they loosen it and also weaken biological resistance, changing the soil's overall characteristics and susceptibility to erosion. Cattle grazing causes an increase in bulk density. This severe compaction reduces availability of water and air to roots, in turn reducing plant growth. Compaction and grazing from cattle has a negative impact on soil fauna such as earthworms in the uppermost 10 centimeters of soil. Soil fauna play an important role in soil porosity, soil structure, decomposition, and many more functions. A Colorado study found that within 3 years, water runoff from a grazed watershed was 30% worse than that from an ungrazed watershed. Greater runoff leads to an increase in unwanted soil erosion and loss of organic matter. Moderate to heavy grazing also led to a whopping 50% decrease in infiltration rates. Thus, intense grazing increases runoff, disrupts the hydrologic cycle, and diminishes plant growth.
Cows' manure and urine lead to nutrient imbalances in soil. Urine's high concentration of nitrogen burns vegetation and is often toxic to plant roots, which cannot immediately recover to take up the nitrogen. Excessive additions of nitrogen from the urine also inevitably affect groundwater and the atmosphere. When a cow urinates on soil, it produces nitrous oxide, a potent greenhouse gas that is eventually released into the atmosphere and causes acid rain. Manure and urine are both means of fertilization by nitrification. Cows that are grain-fed have increased levels of nitrogen in their manure compared to grass-fed cows. Most confined livestock are grain-fed, and their manure is generally dumped into waste pools. Instead of being reused as productive fertilizer, it is allowed to seep into soils and waterways.
While manure additions can be useful in increasing a soil's nutrient levels and organic content, much of this potential fertilizer is wasted due to its abundance. As a result, grazing lands and their surrounding ecosystems face irregularities and nutrient balances. By diversifying crop cover type, ranchers can increase ecological and microbial diversity while also reducing soil erosion. Furthermore, by maintaining plant populations that are resilient to moderate grazing and plants that have high root length densities, the nutrient additions resulting from grazing livestock manure can be naturally managed. By integrating proper grazing rotation techniques that focus on allowing flora sufficient time to recover from trampling and nutrient additions, cattle farmers can preserve soil health. One such practice involves the utilization of silvopastures, the integration of livestock, pasture, and trees. In an 11-year-long silvopasture study done in Oregon, soils in silvopastures were denser, had lower water infiltration rates, and less air-filled pore volume than those in forests, which is consistent with the detrimental effects of cattle on a regular pasture. However, when grazing ceased in the silvopastures, the soil had a quick recovery rate and was able to sustain plant growth, indicating the potential for a sustainable livestock grazing strategy if it is paired with cattle plot rotations. By properly managing rangeland and minimizing grazing intensity, cow farmers can more sustainably raise grass-fed beef and dairy. Unfortunately, America's unsustainably high demand for cattle byproducts has led to the overuse of environmentally harmful practices like factory farming and overgrazing.
So how can you help? As a consumer, you have the power to vote with your dollar. You can do your part to save soils and ecosystems by decreasing or eliminating your intake of beef and dairy, and only eating local and truly sustainably raised cattle products. When consumers care, it transforms markets and shifts how billions of animals are raised.